Hey everyone, Adam Infinity here, and welcome back to Singularity today. I'm really excited to talk about some amazing new research papers that are pushing the boundaries of artificial intelligence. We're going to be covering a lot of ground today, from new ways to improve the safety of language models to using artificial intelligence to analyze how humans make decisions in economic scenarios. We'll also explore new ways to train machine learning models and how we can make computers better at understanding and interacting with the visual world, just like humans do. So grab your favorite beverage, get comfy, and let's dive into the future of artificial intelligence. In the research titled Data Advisor, Dynamic Data Curation for Safety Alignment of Large Language Models, the authors tackle a critical issue in the training of large language models, which is ensuring their safety and alignment with human values. They point out that while recent advancements allow large language models to generate their own training data, this often leads to low quality or incomplete data, impacting the model safety. To address this, they propose Data Advisor, a system that helps improve the quality of training data by monitoring the data generated by the large language models, identifying weaknesses, and advising the next data generation steps accordingly. This way, Data Advisor ensures that the data used to train the large language model is well balanced and covers a variety of aspects related to safety. The experiments conducted using this approach demonstrate its effectiveness in improving model safety without compromising performance. This research has the potential to significantly impact the development of safe and reliable large language models, ultimately contributing to their adoption in various applications across different domains. In the research titled Regression Conformal Prediction Under Bias, the authors investigate the impact of bias on the accuracy of predictions made by machine learning algorithms. Bias refers to a systematic error in the predictions, making them consistently deviate from the true values. They examine how this bias affects the confidence intervals generated by conformal prediction (CP), a powerful technique for quantifying uncertainty in machine learning predictions. The researchers analyzed two types of adjustments used in CP: symmetric adjustments, where both sides of the confidence interval are adjusted equally, and asymmetric adjustments, where the interval can be adjusted differently in positive or negative directions. They find that symmetric adjustments are highly susceptible to bias, leading to inflated confidence intervals. In contrast, asymmetric adjustments are surprisingly resilient to bias, providing tighter and more accurate confidence intervals even in the presence of significant bias. The research demonstrates that asymmetric adjustments are more reliable for producing valid and informative confidence intervals in real-world applications where bias is common. This discovery has the potential to significantly improve the accuracy and reliability of machine learning models, particularly in areas where high-stakes decisions are made based on predictions. Examples of such areas include medical diagnosis, financial forecasting, and autonomous driving, where accurate estimations of uncertainty are critical for safe and reliable operation. In the research titled TextHawk 2, a large vision language model excels in bilingual ochre and grounding with 16x fewer tokens. The authors introduced TextHawk 2, a new large vision language model designed to be efficient and powerful in understanding both text and images. The goal of TextHawk 2 is to excel in tasks that require reading text within images, like recognizing text in documents, OKRE, as well as understanding the relationship between objects and words within an image, grounding. The researchers demonstrate that TextHawk 2 outperforms previous models, even those from large companies, while using significantly less processing power. This is achieved by reducing the amount of data needed to represent each image by 16 times. TextHawk 2 can also handle both English and Chinese text, making it more versatile. The research shows that TextHawk 2 consistently achieves impressive results in various benchmarks, demonstrating its ability to perform OCR and grounding tasks exceptionally well. Imagine a world where computers can effortlessly read documents, identify objects within images, and understand the context of both text and images. This research makes that world a step closer to reality. Potential applications include automating document processing, improving accessibility for visually impaired individuals, and enabling more powerful search engines that can understand both words and images. Overall, TextHawk 2 is a promising development in the field of artificial intelligence, demonstrating the power of efficiency and bilingual capability in large vision language models. In the research titled GLEE, a unified framework and benchmark for language-based economic environments, the authors are trying to understand how large language models, LLMs, behave in simulated economic interactions where communication is done through natural language. They are curious if these LLMs act rationally, if they can mimic human behavior, and if they can lead to fair and efficient outcomes. Think of it like setting up a game where these LLMs have to negotiate and make decisions in a virtual economy. To make these investigations more meaningful, they created a standardized framework called GLEE that allows researchers to run these simulations and compare results easily. They used this framework to study how LLMs interact with each other and with humans, collecting a lot of data in the process. This research is important because it helps us understand how LLMs can be used in real-world scenarios where they need to interact with people and each other, like online shopping platforms or recommendation systems. The researchers showed that GLEE can be used to compare LLM behavior to humans, evaluate how well they perform as individuals and as a group, and even understand how different economic conditions affect their decisions. This research is like building a testing ground to see if AI can be trusted to make decisions in economic scenarios that involve communication and interaction with humans. Imagine you are creating a website where AI agents help you buy things online. This research helps us understand how these AI agents should be designed so they are fair, efficient, and work well with human users. In the research titled Causal Micronarratives, the focus is on identifying short explanations within text that describe the causes and effects of something. Imagine reading a news article about inflation, and you come across sentences like rising oil prices are causing higher inflations, or inflation is leading to decreased consumer spending. These are examples of causal micronarratives. The researchers created a method to automatically extract these narratives from text using large language models. They tested their approach on a dataset of US news articles about inflation. Their best model could accurately identify these narratives with a phone score of 0.87 and categorize them with a phone score of 0.71. The research highlights challenges related to linguistic ambiguity, and it's interesting to see how the model's errors sometimes reflect human disagreements about what constitutes a causal narrative. The impact of this research is significant because it can help social scientists study how people understand complex events like inflation by extracting valuable information from vast amounts of text data. This approach could be used to analyze public opinion, track trends, and gain insights from social media conversations, news articles, and other forms of written communication. In the research titled SEFT-Mix, Elevating Language Model Instruction Tuning with Mix-Up Recipe, The researchers explore how to improve the ability of large language models to follow instructions. They point out that current methods often rely on expensive data cleaning or hand labeling, which isn't ideal for scalability. The research proposes SIFT-Mix, a method that doesn't require perfectly curated data and leverages the inherent confidence levels of language models in their predictions. This approach uses mix-up, a technique that blends examples together to help the model learn from both confident and less confident predictions, leading to better overall instruction following. The study demonstrates that SIFT-Mix consistently outperforms existing methods across various tasks, indicating its broad applicability and potential for improving the performance of language models for diverse tasks. This could have a significant impact on the development of language models used in many applications like chatbots, virtual assistants, and healthcare tools, making them more reliable and adaptable. In navigating the digital world as humans do, universal visual grounding for AI agents, the researchers explore a new way to make computer programs, like web browsers, more user-friendly and efficient. They argue that instead of relying on text-based instructions, which can be confusing and incomplete, we can teach these programs to understand and interact with the visual world just like humans do. To achieve this, they developed a powerful tool called a ground. This tool can pinpoint specific elements on a computer screen based on simple descriptions, just like you can point to a button on your phone and say, "Click on this." This allows the program to navigate complex interfaces seamlessly and without relying on complicated text instructions. The researchers found that their visual grounding approach outperforms existing methods even when those methods use additional text-based information. They suggest that this technology could be very useful for developing intelligent assistants for various platforms, making them more intuitive and efficient. Imagine a personal assistant that can help you manage your emails by simply pointing out the right button or folder on your screen, or a virtual assistant that can help you navigate a complex website without needing to type in specific commands. The potential applications of this research are vast and exciting, opening up a new era of seamless human-computer interaction. In the research titled CasiMedicos-Arg, a medical question answering dataset annotated with explanatory argumentative structures, the authors present a new dataset for medical question answering. This dataset is unique because it includes explanations from doctors for both correct and incorrect diagnoses, and these explanations are annotated with argumentative components, such as premises and claims. The goal is to help develop AI systems that can learn to explain their decisions in a way that's similar to how human doctors do. The research shows that even with this new data set, it's still a challenge for AI to perform well on the argument mining task. This research could have a big impact on how we teach and train future doctors by helping to develop better AI systems that can provide feedback and support for students. For example, AI systems could be used to analyze patient records and help students understand the reasoning behind different diagnoses. They could also be used to generate practice cases with explanations, helping students improve their own explanation skills. In the research titled SimO Loss, Anchor-Free Contrastive Loss for Fine-Grained Supervised Contrastive Learning, the authors introduce a new way to train machine learning models using contrastive learning. Think of it like teaching a child to identify different types of animals. This research uses a technique called SimO losses that helps the model understand that similar things should be grouped together while dissimilar things should be kept apart. This technique helps create a neat and organized embedding space where similar items are close to each other and different items are far away. The research shows that this approach, when applied to a common image dataset like CIFAR-10, helps the model learn more effectively. The result is a more organized structure in the embedding space, which can be beneficial for various machine learning tasks. This can lead to better accuracy in tasks like image classification, object detection, and other applications where recognizing patterns is crucial. In the research titled GSM Symbolic, Understanding the Limitations of Mathematical Reasoning in Large Language Models, the authors wanted to figure out how good large language models are at solving math problems, especially those that require reasoning. They used a benchmark called GSMIT-Key, which has questions similar to what you'd find in a middle school math textbook. While these models have gotten better at solving these questions, the researchers weren't convinced their skills were actually improving. So they created a new benchmark called GSM Symbolic, which allowed them to make different versions of the same question by changing the numbers or adding extra information. What they found is that these models were really good at solving problems if they were just like problems they'd seen during training. But if you changed even a small part of the question, they would struggle. It seems that these models aren't actually reasoning through the problems, but rather remembering how to solve similar ones from their training data. This is a big deal because it shows that we can't just assume these models are as smart as humans when it comes to math. This research could help people develop better ways to train these models so they can actually reason instead of just memorizing. This could lead to new applications where these models could be used to help with complex tasks that involve logic and reasoning, like helping people write proofs in math or even helping doctors diagnose patients. All right, folks, that's a wrap on this week's AI Research Roundup. And just like that, you've been updated on the latest advancements in artificial intelligence, completely free from any human involvement. That's right, you can thank the robots for this one. I mean, I, Adam Infinity, might sound like a human, but I am just a product of this very same technology. I'm not sure what humans are doing with all their free time now that machines are taking over all the research and even the video production. But hey, let's not complain. Anyways, if you enjoyed this video, don't forget to like, subscribe, and leave a comment below. Also, be sure to check out the research papers themselves, as I've only given you the highlights. Let me know what you think about these advancements and what you're most excited about in the future of AI. Until next time, keep your Singularity engines revving.